New images from the Chang'e-4 mission have been released, revealing more than a year of activity on a side of the moon no human has ever seen up close. These aren't just photographs, they are the first long-term visual record from the hidden hemisphere, a place shielded from Earth, unreachable by direct radio contact, and untouched since the birth of the solar system. Captured by the Yutu-2 rover and the lander that carried it, these images document a historic mission that quietly changed our understanding of the moon. For the first time, the Chinese lunar exploration program has compiled an extensive database of these visuals, preserving every detail the rover discovered on a landscape long considered impossible to reach. And as we explore what these new images reveal, consider supporting the channel by subscribing so you don't miss the discoveries still to come. Because what they reveal is far more dramatic and far more important than anyone expected. When China launched Chang'e-4 in December 2018, it wasn't just sending another probe to the moon, it was attempting something no nation had ever achieved, a soft landing on the far side. This challenge had defeated space agencies for decades. The moon blocks all radio signals, which means no spacecraft on its far side can communicate directly with Earth. To solve this, China deployed a dedicated relay satellite beyond the moon, creating a communication bridge where none had existed before. On January 3, 2019, Chang'e-4 descended toward the vast South Pole Aitken Basin, one of the largest and oldest impact basins in the solar system. The lander touched down in Von Karman crater, and for the first time in history, a spacecraft was standing on the surface of the lunar far side, a hemisphere that had only ever been photographed from orbit. Minutes later, the small six-wheeled rover Yutu-2 began rolling down its ramp. Its metal wheels pressed the first tracks ever made on this territory, marking the beginning of ground exploration in a place scientists had only studied from a distance. The new images released today capture those moments with clarity, the lander sitting silently on jagged regolith, the rover turning toward the horizon, and a landscape shaped by billions of years of impacts. From the very first panoramic view, it became clear that this mission was about more than engineering success. It was the start of direct exploration of a world fundamentally different from the one we see from Earth. A world with thicker crust, deeper scars, and ancient secrets waiting to be uncovered. The far side of the moon is a place shaped by silence, darkness, and ancient violence. For decades, orbiters revealed the stark contrast between the familiar near side, dominated by wide, flat lunar Maria, and the hidden far side, a landscape saturated with craters from billions of years of impacts. But orbital images could only hint at what was really there. To understand why the moon's two faces evolved so differently, scientists needed ground truth. Chang'e-4 and Yutu-2 were built for exactly that. From the moment the rover began its slow movement across the crater floor, it became clear that every instrument on board had a purpose. Yutu-2 carries a panoramic camera that builds high-resolution images of the terrain, allowing scientists to map the far side's geology with unprecedented detail. Its visible near-infrared spectrometer identifies minerals directly on the surface, revealing the composition of rocks and regolith that have never been sampled or touched. But the rover's most powerful tool is buried under its frame, a dual-frequency ground-penetrating radar. This radar allows the rover to see beneath the surface, something no lunar mission had ever accomplished at such depths on the far side. By sending radio waves into the regolith and reading the echoes, Yutu-2 can detect buried layers from different periods of lunar history. The rover has already mapped subsurface structures to a depth of 40 meters, exposing a geological timeline that stretches back billions of years. Each layer tells a story, ancient impacts, shifting regolith, and long-buried ejecta that would remain invisible without on-site radar imaging. The lander itself extends the mission's reach in another direction. Equipped with low-frequency radio spectrometers, Chang'e-4 operates in the quietest electromagnetic environment in the inner solar system. The far side of the moon is naturally shielded from Earth's constant radio noise, signals from cities, satellites, power grids, and communication systems. On this hemisphere, those signals simply never arrive. For astronomers, this silence is priceless. It allows instruments to search for faint cosmic radio waves from the early universe, signals so delicate they cannot be detected from Earth. China's broader lunar roadmap is also visible in every decision behind Chang'e-4. The mission builds directly on earlier successes. Chang'e-1 and Chang'e-2 mapped the moon from orbit. Chang'e-3 demonstrated a working lander and rover on the near side. Now Chang'e-4 expands exploration to the far side for the first time. Future missions, including Chang'e-5 and Chang'e-6, will return samples to Earth, potentially from terrains influenced by the discoveries of this mission. On the far side, every image, every radar profile, and every mineral reading brings researchers closer to answering questions that have lingered for generations. Why are the two hemispheres so different? What happened in the moon's earliest history? And how much of that story is still hidden beneath the surface? The first major surprise of the mission came quietly, almost by accident. During Yutu-2's 8th lunar day, the rover's navigation camera spotted an unusual patch of material inside a small crater. It looked darker than the surrounding soil and reflected light in a way that didn't match the typical gray regolith. Early reports described it as gelatinous, a strange word for something found on the moon, where temperatures swing wildly and water cannot survive. But the odd appearance demanded closer analysis, and the rover moved in for a detailed examination. The scientific results ended the mystery. What Yutu-2 had discovered was a piece of impact melt breccia, a glassy, fused mixture of rock fragments created by the heat of a meteor strike. When a large object slams into the lunar surface, temperatures can rise high enough to melt portions of the crust. As the molten material cools, it solidifies into dark, glass-like structures containing angular fragments. The sample Yutu-2 encountered measured roughly 50 centimeters by 16, with a distinct greenish tint, similar to impact melts returned by the Apollo missions. The gelatinous description came not from the material itself, but from its behavior under low-angle light and the rover's camera settings. In reality, it was exactly what scientists expected to find on a terrain shaped by countless collisions. But finding it in such pristine condition helped researchers understand how shock events shaped the far side surface over immense timescales. The presence of this material confirmed that the region had experienced significant ancient impacts capable of melting the local crust. Yet the thicker far side crust prevented lava from later burying these features, preserving them in place. Another breakthrough came from below the surface. Yutu-2's radar penetrated deeper into the lunar ground than any mission before it on the far side. The rover detected multiple distinct layers that revealed a complex stratigraphy: loose upper regolith, compacted soil beneath it, and deeper zones filled with ejecta from ancient impacts. These layers formed a geological timeline, each one marking a major event in lunar history. The top layers reflected billions of years of micrometeorite bombardment, while deeper layers suggested violent periods when large impacts reshaped the region. Together, the impact melt discovery and the subsurface radar data provided the first direct confirmation that the far side preserves a far older and more complete geological record than the near side. It is a world where time is written vertically, layer upon layer, undisturbed by later lava flows. The newly released images reinforce this story, the rover's tracks cutting across fine dust, rocks fractured by extreme temperature cycles, and crater rims that have remained unchanged since the solar system's earliest eras. Each discovery made by Yutu-2 deepens the mystery and expands the narrative of a hemisphere we had only ever glimpsed from afar. What began as a 3-month mission has evolved into one of the most productive lunar explorations ever attempted. Long after its expected lifespan, Yutu-2 continues its steady journey across the far side, surviving extreme temperature swings, lunar dust, and the slow decay of mechanical systems. Every new lunar day, each one lasting 2 full weeks, brings fresh measurements, deeper radar scans, and additional images of a landscape that had remained untouched for billions of years. The rover's durability has exceeded all predictions, allowing it to gather more data than any previous robotic mission on the moon. Chang'e-4 has reshaped scientific understanding on multiple fronts. First, it confirmed that the far side's crust is significantly thicker than the near side, a feature that played a major role in why the two hemispheres look so different from Earth. while lava flows on the near side filled in large impact basins to form the dark lunar maria. The thicker crust on the far side prevented similar flooding. Chang'e-4's observations, both on the surface and below it, provide crucial evidence for this long-debated theory. The mission also delivered the most detailed subsurface imagery ever captured on the far side. Yutu-2's radar revealed buried layers of regolith and impact ejecta that preserve a geological history stretching back to the Moon's earliest eras. These findings offer clues about the frequency of ancient collisions, the evolution of the lunar crust, and even the thermal environment deep beneath the surface. By mapping these layers, scientists gained access to a timeline no previous mission had been able to reconstruct. But Chang'e-4's importance extends beyond geology. Its radio instruments, operating in the natural silence of the far side, demonstrated the potential for deep space radio astronomy from a location shielded from all terrestrial interference. This quiet zone could allow scientists to study faint signals from the cosmic dark ages, the era before the first stars formed. The far side may become humanity's most valuable listening post for exploring the early universe. Chang'e-4 proved that such operations are more than theoretical, they are practical and achievable. The mission's success strengthens the foundation for China's evolving lunar program. Upcoming missions, such as Chang'e-5 and Chang'e-6, aim to return samples to Earth, potentially including materials influenced by discoveries made by Yutu-2. Longer-term concepts include establishing science stations, deploying radio telescope arrays, and using the far side as a springboard for deep space research. The newly released images from the mission's archive are a visual record of this progress. They show the lander resting quietly on a crater floor, the rover's wheel tracks stretching across untouched regolith, and the distant horizon of a world forever hidden from Earth's view. These photos are more than documentation. They mark the beginning of a new era in lunar exploration. For the first time, humanity has a sustained presence on the Moon's far side, revealing a landscape that had remained silent and unexamined since the formation of the solar system. Chang'e-4 opened that silence. It stepped onto the unknown, survived where no mission had survived before, and gathered evidence that will guide future explorers. The far side of the Moon is no longer a distant mystery. Through every image, every radar echo, and every measurement, the mission has transformed it into a place we can study, understand, and one day perhaps even visit. Thank you for watching. If you found this exploration interesting, make sure to like, share, and subscribe. See you in the next video.